For those classes that aren't physics that I share this video with, I do use a physics example in here, and I talk about a couple of physics topics that will be referred to later on. The how to graph is still the same for you. The whys and some of the applications maybe are a little bit different, but I apologize that the video has kind of a physics emphasis. You're probably going to watch this in reverse order of what I'm actually recording it here, but I'm getting ready to record the motion graphs video, and as long as I had this data table set up and ready to graph the data, I thought I'd show you how to graph here in Google Sheets, which is in Google Drive. So I have this file already created, and I'll share it out with this video here so you can follow along and do this if you'd like. As a side note, if you've not done it before, you can do a side-by-side window thing if you're on a Windows computer right now. If you grab this, and it won't do it actually on the Mac side, but if you grab up here in the title bar and then you bring it over to the edge, it'll kind of pop for a moment, and then it will put it on just one side of the screen, and then you can grab the the video and put it on the other side of the screen, and you can actually have it side by side instead of doing window switching. On the Mac side, I don't know of a default way to do it, but I have downloaded a program called Spectacle that lets you use a keyboard command to then put stuff on one side or the other. And I use it a lot there on the Mac side. On Chromebooks, it's up here where your minimize and maximize buttons are. If you hold the minimize button, or the maximize button, I think it is, it'll bring little greater than, less than caret arrows up there, and you can tell it to pop onto one side or another. On tablets, I don't know of a way to do it. Most tablets don't multitask very well anyway. But if you'd like to split screen it, there you go. So that's just an added bonus on how to split screen here. But I thought I'd show you how to graph in Google Sheets. I also will be posting separate videos on how to graph in other programs. The basic process is the same for any spreadsheet program. So anyway, I've made up fictional data here, and the color coding I picked here is based off of the default colors that the graph will be, and I've already looked that up for this particular software program, so I graphed the data and then deleted the graph, but I have made it match. You would probably have black data, and you would have to figure out which line it colored which, and you can customize the colors if you want to. I'm going to show you the basics. You can add all the bells and whistles that you want to. Anyway, let's get into graphing this stuff. So in Google Sheets, it is incredibly important that the first column you have is your X column. That column are your X values, your X axis. Anything else is going to be considered a Y value. So, of course, you only have one independent variable, but you might have multiple different trials, which is what I have here, are different situations where we have an object moving, and again, this is fictional data. The numbers come out perfectly here, which you would not expect in real-world data, where you have human error with your timing and your measuring distances coming into play and throwing off your data. But anyway, your first column here is your X value, but let's say we want to do the distance versus time graph. What I'm going to do is I'm going to highlight the times that I'm interested in, and I've included the header there. And then keyboard shortcut is Control on the Windows side or Command on the Mac side to highlight multiple things at the same time. So I'm going to highlight all of my distance columns here, and then it's Insert Chart. Now it tries to guess what kind of chart you want, and frequently it will have scatter here under its recommendations, but it always has scatter under its chart types if you come down here, and we always want to do scatter plots in science. So there we go, we picked the scatter chart, and that's actually pretty good. I don't love this axis here, and I wish I could retitle these, but the only way to retitle those is actually come in here and retitle them up here, and I could call this one distance, CV for constant velocity, and then SCV, and so on and so forth, and it would change them there. I'm not going to do that on this one. But anyway, a little bit on customization. So title, we always title graphs Y versus X, and so for us, the Y here is distance, and the X is time. The legend over here, you can change where it's at or not have one. I've never seen that one before. That's a new feature. I don't know that I like it. But anyway, horizontal axis here. To edit the axes, you actually have to pull them from the pull-down menu. In other programs, it's horizontal axis, then vertical axis, but that's okay. So this one is time in seconds. And you can play with the font, and you can play with the labels, and the slant labels puts the numbers in there at an angle. If you have lots of information, sometimes it's nice to make it at an angle and turn the text sideways. Anyway, you can also set what your minimum and maximum value is. It picks what it thinks it should be. But I have picked my, I'm happy with that. On occasion, I'll trim it down, trim down the window. I rarely pull it up. Anyway, grid lines are these grids here, kind of making it look like graph paper, and you can add in extra grids if you want. You can play with their colors and all that. Number format, I never mess with. I just use it the way the data is there. But if you wanted to add decimals or take away decimals for sig figs, you could customize that. Later in the year, we'll do logarithmic graphing, and if you'd like one scale to be log, then you can do turn it log with that checkbox there. And then here's where you can edit your individual colors. So I'm not thrilled with how big the dots are here for the graph, so I'm actually going to take the time here, and I'll try to fast forward through this part to pick on each of these a smaller dot. You can play around with customizing the colors on the dot. I've already made my data match to that, so I'm not going to do that. But the sizes here I am going to change, and you can pick from the defaults, or you can type in your own. And I'm going to try to speed through this. And there you go. You can also change the shape if you want. I never do that. Unless I know I'm going to be printing in black and white, and then I might change the shape of the dot and have shapes instead of colors be my thing there. Data labels I don't turn on, but basically you can put in the Y value here. It does not give you your XY coordinates, so I don't think that's all that useful. But it takes a little bit of getting used to do graphs in a spreadsheet program like this. Oh, and I forgot to do my other axis. Left vertical is distance. And I don't actually have units, but let's pretend it's meters, since I made it all up anyway. So the real power of graphing in a program like this is the fact that you can add a trend line. And so you may notice that there's some patterns in the data, and you can tell it to do a line of best fit. And so you might think that the trend line here is linear, that it's a straight line, and it will give you the equation, notice, on the screen, and that is a y equals mx plus b equation. You can even have it, instead of having a label that says trend line, you could tell it to use the equation as the trend line. And then you can change the settings of the line thickness and the color again. I'm not going to play with that, but what I am going to do is add in my other trend lines for each data point, and that becomes really useful for doing your figuring out what the relationships are. And so that's the real power of doing this. The other thing that I could do, in addition to showing you the equation, which I didn't do on the first one and need to go back and do, is you could show an r-squared value. And the r-squared value here is kind of nonsensical since I made up perfect data, and it's all going to be the same r-squared value. But the r-squared value, when you have random scattered data, is a statistical analysis. I'll be honest, I don't know what statistics they're applying to it. I just know that that's what's being done. That basically says, how well does the line fit your data? And it's essentially a decimal percent. So here we have 1, multiply that by 100, and we have 100% accurate, which isn't a surprise because I made up perfect data. But in the real world, your data is going to be slightly higher, slightly lower, and because of that, then you will have some ugliness and some randomness to the data, but you can figure out, is this the real relationship? That becomes even more important when we get to ones that are not linear. So my last two here happen to be not linear, and so if you look at this, here, when I put in a linear line, that doesn't fit the purple dots all that well. And if I show the r-squared value for that one is, unfortunately, off the screen. But it is not going to be 100% because that one's not a linear relationship. And if we come in here instead and tell it it's an exponential relationship, that doesn't look quite like it. But a polynomial, that looks like it fits the data better. In fact, I see a 100% relationship there. And this I would expect to be parabolic in shape, and so then it's a polynomial of order 2. It does turn out that if you go to a high enough order polynomial, any bad data can be made to fit, but that's probably not the true relationship. So you do have to be careful and have a good reason to justify using a polynomial higher than, say, order 2. But if you have decent data, then usually polynomial order 2, if it's not linear, is good enough to catch the relationship there. So I'm going to slap in the last few trend lines here and speed this along. And that's really it. To clean up my legend over here, since I'm graphing so many things, I'm going to go back through and turn off the r-squared values. But normally when I do a trend line, it's trend line show equation shows the r-squared value. In some programs, they will let you add 0, 0 as a data point. I actually typed 0, 0 as a data point across the board, so that's not an issue here. But that 0, 0 data point comes up by, it says set the y-intercept usually. And so then you can tell it what the y-intercept is if you know what your starting value is, but it wasn't in your data. And think about it, is 0, 0 part of your data? And if so, go ahead and include it, and it will do that. This program doesn't let you do that, but I'm going to clean this up a little bit. So now that I've cleaned all this up, I'm going to insert the graph into here and then reposition it so it's underneath there. Now this is kind of tiny and hard to read, so one thing that you can do is you can make it its own tab down here, make it its own sheet, and then it takes up more space and your stuff shows up better. And so that's usually what I will do, and I will usually rename this, this is my distance versus time graph. And so then here you can have your chart, and you can do all sorts of other things to fancy it up if you'd like. You can print it, save the image, do all sorts of stuff with it, and that is this. Also, nicely, if you come back here and you modify your data, the graph will update in real time there, and of course you can have groups working together in terms of graphing or collecting the data together with sheets. You can have multiple people working on this at the same time, so no one person gets stuck with having to graph everything. You can each, I'll put in the data for this and graph that, and I'll put in the data for that and graph it, and you can all work together on that. But that's the real power of Sheets that I love, and all of the Google Docs, is the ability to edit anywhere you go and edit together. Multiple people editing at the same time. Anyway, that's basics of how to graph in Sheets here. I got a couple other graphs to make, so I'm going to work on those. But be sure, if you have any questions, that you jot them down and bring them with you to class.